Hi, one and all. So today we are going to discuss about this problem: count elements with at least k greater values. Let's see the question first. You are given an integer array nums of length n and an integer k. An element in nums is said to be qualified if there exist at least k elements in the array that are strictly greater than it. Return an integer denoting the total number of qualified elements in nums. Okay, so the question is, we are given an array, okay, an integer k. We have to denote the total number of qualified elements in nums. Now the question is, what are the qualified elements? An element in nums is said to be qualified if there exist at least k elements in the array that are strictly greater than it. It means, see, we have to return the total number of qualified elements. What is a qualified element? There should be at least k elements which are greater than the number. Okay, let us understand with this example. Okay, we have like 3, 1, 2. Okay, if you see here 3, how many numbers are greater than 3? That means 0. 0 numbers are greater than 3. But we need at least k elements, so this is not counted. Let us go to 1. Okay, if you go to 1, how many are greater than 1? 3, 2. It means 2. We have at least one element. It means I can increase the count to, like, now the count is 1. If you go to 2, how many numbers are greater than 2? 3. It means at least one element we have greater than 2. So we have 1, 2. So the answer is 2. In the same way, if we take 5, 5, 5, for 5 there are no strictly greater than element than that. Okay, we need at least two elements which are greater than 5, but there are no. So that's why the answer is 0. Okay, so now the intuition can be, first we can solve like use two for loops. For each element, count how many numbers are strictly greater than it. But the time complexity for this would be order of n square, but we have here time constraint which is 10 power 5 nums length, so we can't do that in n square. We need at least n log n. We can solve in n log n or order of n, like that. I mean, maximum is order of n log n. So the intuition can be, we need greater elements. Okay, one for loop we can remove from the two for loops. So in order to do that, we can just sort the element. Okay, we can, I mean, not elements, we can sort the array. When we sort it, what is the value? 1, 2, 3. Now I will start iterating from the last. Okay, first I will going at 3, then I will check how many numbers are greater than 3. Up to now, nothing. Okay, so the count is simply 0. Okay, next I will be going to the 2. Okay, if I go to the 2, then how many elements are greater than 2? One element. So I'll be increasing the, like, when I'm here only I'll be increasing the count, and previous value is 3. So when I come here, previous value is greater than that. It means that there is no equal, so I will be just increasing the count to like count. I'll be checking the count. So count is greater than k, I mean greater than or equal to say k, so answer is 1. Now my previous value will be 3 and count will be 2, because there are two elements like for the previous next one, and the previous value is 2. If I go to 1, how many are greater than 1? There are 2. Two values are greater than 1. Okay, so it means it is also qualified. Okay, I will be increasing the count to 2, 2, and previous is 1, and I will be running out of the loop. I mean, the loop is ended. So in this way I'll return the answer as 2. Okay, so now we will be getting the question why we have to iterate from the last, not from the first, and why we need to use the previous or the previous value. We can just use count value, right? Or without we can cut down these two values, but why do we need to use these two variables, and why we need to iterate? Okay, let me tell you the answer. So whenever we will be given the duplicates, then the normal thing won't work. I mean, definitely we need this too. Okay, let me write this one. So it is like 2, 5, 6. So as I discussed, let us say I will be iterating from the first. I will be iterating from the 0th index. Why it won't work, I'll say, and why we need to use those two variables. So I am here too. I have checked how many values are greater than 2. I can just directly see like this is a value which is greater than 2, right? So I can just directly check, okay, n minus 1 minus ith index. So it's like 0, 1, 2, 3, 4. Okay, I will be checking like n minus 1 minus I index. Okay, so that means we have like 4 minus 0, so 4 indexes which are greater than k. So I'll be increasing the count to 1. Okay, we have at least 4 elements, so I'll be increasing the answer as 1. Okay, then I'll be going to the next element, 4. Okay, so as I said, n minus 1 minus I. So what's 4 minus 1. So we have how many elements greater than 3? 2 elements. Sorry, 4 minus 1, like 3 elements which are greater than 3 is greater than k, so I'll be increasing the answer to 2. Then I'll be coming here. After coming here, I will be seeing whether the answer is like, I will be seeing how many elements are greater than 5. If I didn't consider the duplicate value, the answer would have been 2. But the answer is it is only one element which is strictly greater than 5. Either I have to maintain a variable like how many values are same. Okay, let us say from here I will be traveling up to the element which is unique. So from there again I have to count like that. From first also we can do, but we need to maintain a variable like how many continuous, how many duplicates values are there. So in that way we can do that. So instead of blindly following, we can just maintain a variable which is like similar or same. Sorry, my naming the variable is kind of different, so I can just increase the same variable up to it founds different value, then I can increase. So due to this reason we have to maintain one variable which is called the same. Okay, then we understood. We can do either from the first or we can do from the last, but I have done it from the last. Okay, so I'll be coming from here. Okay, up to now the count value is it's a count value is 0 and the previous value is nothing is there. So my k value is 1. Do we have at least k elements which are greater than 6? No. So I'll be just answer is same. Okay, and how many are, okay, up to now the count is 1 before it going to the previous one. So count is also 0. Okay, it's kind of clumsy, I guess. I can just remove, and let me keep it as count is 0. Now count has increased. The previous value is 6 now. Okay, it is 6. Now I'll be going here. So when I go here, I will be seeing whether previous value is greater than present value. Yes, of course it is greater than 6 is greater than 5. So then I will be checking the count. Okay, I'll be checking the count. The count is 1. At least k elements are there. So then I can increase the answer. Okay, now I have to store how many similar values are there. So up to now the same, before going to previous element, the same is 1. Then I'll go here. Okay, if I go here, I will be checking whether the previous value, previous value also we have to update. So previous value is similar to the present value or not. Oh, it's same. So then we can't update the count value also, because it's only one element. And okay, instead of k equal to 1, let's keep k equal to 2, because that will be good for this error case handling. So yeah, so here like for 6 now no values are there, for 5 also only one value is there, so up to now our answer is kind of 0 only, so we can just keep answer as 0. Okay, next when I come here 5, so the previous, it's equal to the previous value and the count is also 1, so it means we didn't find not at least two values. So I'll be just increasing the same value to the 2. I have chosen the different one, so it is like 2, same values are 2. When I go to here, we have to update the previous, so when we go to here 4, I'll see like before, when it hit different element, no, then we have to increase the count. So when I go to here, the count value is 2. At least I've found 2 elements, so now my answer can be 1. Okay, and what is the previous value before going to the next value? So it's 4. Okay, the count is 3. Okay, if different element is found, and as soon as like it comes to the different element, we can just make the same element as 1, because at least one element is found, right? So then I'll go to the 2. Okay, then I'll see the previous value of course is greater than 2, and the count is 3. It means at least I have 2 elements, so my answer will be become to 2. Okay, though, so yeah, same is now 1. Okay, I'll go here, this is the end of the loop, so answer is 2. You can just return like this. Okay, so answer is we can return. And the time complexity is for sorting, it's n log n. Okay, so and for traversing, okay, so for traversing it is n, so it is overall n log n. And the same space complexity is previous, we can say like order of 1, because we have like 2-3 variables like previous number and count and answer and same, so it's order of 1. So in this way we can solve this problem. Thank you.